Learning objectives. At the end of this topic, you will be able to measure the surface area of the following 3D shapes: cuboid and cubes, right circular cylinder, right circular cone, and sphere. So far in all our study, we have been dealing with figures. Any figure that can be easily drawn in a plane is called a plane figure. It would be interesting to see what happens if we cut out many of these plane figures of the same shape and size from cardboard sheet and stack them up in a vertical pile. By this process, we shall obtain some solid figures such as a cuboid, a cylinder, etc. In this lesson, we shall learn to find the surface areas and volumes of cuboids and cylinders in detail and extend the study to some other solids such as cones and spheres. Surface area of a cuboid and a cube. To form a cuboid, first we would need a rectangular piece. This is the bottom of the cuboid. Next, we need two long rectangular pieces to cover the two side ends. Now to cover the front and back ends, we would need two more rectangular pieces of a different size. If you opened it, it would look like this. Finally, to cover the top, we would require another rectangular piece exactly like the one at the bottom, which if we attach on the right side, it would like as shown here. So we have used 6 rectangular pieces to cover the complete outer surface of the cuboid. This shows us that the outer surface of a cuboid is made up of 6 rectangles. The 4 sides of the cuboid represent the 4 lateral surfaces of the cuboid. If we add the area of the lateral surfaces, what we get is called lateral surface area or LSA of a cuboid. Now if we take the length of the cuboid as L, breadth as B, and height as H, then the figure with these dimensions would be like this. We get the areas of each of the lateral faces LH, BH, LH, and BH. So, lateral surface area of a cuboid is equal to 2 times of LH plus 2 times of BH. On simplifying this expression, we get the formula 2 times the height multiplying sum of the length and the breadth. Now let's derive a formula to calculate the surface area of the cuboid. To calculate the surface area of the cuboid, we can apply the formula length into breadth and then add the 6 areas together. The area of the top and bottom of the cuboid is LB and LB. So, the sum of the areas of the 6 rectangles is 2 times of length into breadth plus 2 times of breadth into height plus 2 times of length into height. Now take 2 commonly outside. This gives the surface area of the cuboid equal to 2 times of length into breadth plus breadth into height plus length into height, where L, B, and H are respectively the 3 edges of the cuboid. In a cuboid whose length, breadth, and height are all equal, it's called a cube. If each edge of the cube is A, then the surface area of this cube would be 2 times of A into A plus A into A plus A into A, which is equal to 2 times of A square plus A square plus A square. That's equal to 2 times of 3A square. This implies surface area of a cube is equal to 6A square, where A is the edge of the cube. Suppose, out of the 6 faces of a cube, we only find the area of the 4 faces, leaving the bottom and top faces. In such cases, lateral surface area of cube of a side A is equal to 4A square. Now let us look at this example. A cubical box has edge 5 centimeters and another cuboidal box is 15 centimeters long, 10 centimeters wide, and 6 centimeters high. 1. Which box has greater lateral surface area and by how much? And 2. Which box has the smaller total surface area and by how much? Now, first let's find the lateral surface area for the cuboidal box. A is 5 centimeters. Therefore, the lateral surface area of the cubical box is 4A square, that is 100 square centimeters. Now, we find the lateral surface area of the cuboidal box. L is 15 centimeters, B is 10 centimeters, and H is 6 centimeters. Therefore, the lateral surface area of the cuboidal box is 2 into L plus B into H, that is 300 square centimeters. From the two lateral surface areas calculated, we find that the cuboidal box has a greater lateral surface area than the cubical box by 200 square centimeters. Now let's move on to the total surface area. First, we need to find the total surface area of the cubical box, that is 6a square, which is equal to 150 square centimeters. Now we find the total surface area of the cuboidal box, that is 2 into LB plus BH plus HL, which is equal to 600 square centimeters. By comparing the two total surface areas, the cubical box has the smaller total surface area than the cuboidal box by 150 square centimeters. Surface area of a right circular cylinder. A cylinder can be defined as a solid figure that is bound by curved surface and two flat surfaces. A flat surface is made up of two congruent circles that are parallel to each other. These flat surfaces are called the bases of the cylinder. The radius of the circle is the radius of the cylinder. The perpendicular line that passes the centers of the two circles is the height of the cylinder. Here are a few examples of cylinder. Some of the cylinders are straight and some of the cylinders are not straight. A cylinder with base is circular and with axis joining the two centers of the bases perpendicular to the planes of the two bases is called right circular cylinder. You see a cylinder, which is certainly circular, but it's not at right angles to the base. So we cannot say these kinds of cylinders are right circular cylinder. Now, if a cylinder has to be covered with colored paper, how will we do it with a minimum amount of paper? First, take a rectangular sheet of paper whose length is just enough to go around the cylinder and whose breadth is equal to the height of the cylinder. The area of the sheet gives us the curved surface area of the cylinder. Note that the length of the sheet is equal to the circumference of the circular base, which is equal to 2 pi r. So, curved surface area of the cylinder is equal to area of the rectangular sheet, that's equal to length into breadth, which is equal to perimeter of the base of the cylinder into height, that's equal to 2 pi r into h. Therefore, curved surface area of a cylinder is equal to 2 pi r h, where r is the radius of the base of the cylinder and h is the height of the cylinder. Now, if you cover the bottom and top of the cylinder, we need two circles of the same radii r and thus having an area of pi r square each. This gives us total surface area as 2 pi r h plus 2 pi r square. Now take 2 pi r commonly outside, then it becomes 2 pi r into r plus h. Therefore, the total surface area of a cylinder is equal to 2 pi r multiplied by the sum of r and h, where h is the height of the cylinder and r is its radius. Remember, pi is an irrational number, so the value of pi is a non-terminating, non-repeating decimal. But when we use its value in our calculations, we usually take its value as approximately equal to 22 by 7 or 3.14. Let us look at this problem. A metal pipe is 70 centimeters long. The inner diameter of a cross-section is 4 centimeters, the outer diameter being 6 centimeters. Find its inner curved surface area, outer curved surface area, and total surface area. In the given cylinder, h is 70 centimeters. 2r, that is, inner diameter is 4 centimeter, which gives us inner radius, r is equal to 2 centimeters. Outer diameter is 6 centimeters, which gives outer radius, capital R, equal to 3 centimeters. Now let's find the inner curved surface area, that is 2 pi r h, which is equal to 880 square centimeters. The outer curved surface area is equal to 2 pi capital R h, which gives us 1320 square centimeters. Now we find the total surface area, which is equal to 2 pi capital R h plus 2 pi R h plus 2 pi capital R square minus R square, which gives us 2231.42 square centimeters. Surface area of the right circular cone. Look at these pictures. It is of the famous Pyramid of Egypt. The term pyramid seems to have become almost synonymous with the shape. There are other shapes also that can be categorized as pyramids. Let's look at an ice cream cone kept upside down. It almost looks like a pyramid. Cones and pyramids look similar because they both have a single base and lateral surfaces that join at a common vertex. The difference is in the nature and shape of these surfaces. A pyramid has a flat and triangular lateral surface, while cone has a curved surface. If you look at the bases, the pyramid base is a square and that of a cone is a circle. Remember, the bases of the pyramid can be any polygonal shape. It can be a triangle, a rectangle, or a pentagon. Now coming to the cone, it is solid with a circular base and a curved lateral surface. The tapers in a point are called vertex. Now let's see how a cone is constructed. Let's take a right-angled triangle. If the triangle is quickly rotated along one of its sides, we can see that a figure has been formed. This is a right circular cone. The side along which the triangle is rotated becomes the height h of the cone. One of the two sides becomes the base radius r of the cone. A cone has a slant height L. It's actually the hypotenuse of the right triangle. As you can see, the difference between the height and the slant height. The height is perpendicular to the base of the cone, while the slant height is not. Using the Pythagoras theorem, we get the relationship between L, R, and H as shown. Note, if H is perpendicular, then the cone is called right circular cone. Now let's calculate the total surface area of the cone. The total surface area of a cone comprises the curved surface area called CSA and the area of the circular base. This is called the total surface area or TSA of a cone. However, to find the area of the cone, you need to calculate only the CSA. Let's see how. Here is the sample of a conical cap. If we cut it along its slant height, it opens up to the shape as shown here. The straight edges represent the slant height L. The curved edge represents the edge of the circular base. Hence, the length of the curved base will be equal to the circumference at the circular base of the cone, which is equal to 2 pi r, where r is the radius of the base. Now let's divide the piece into as many triangles as possible. The CSA of a cone will be equal to the total area or the sum of the area of these triangles. The area of each triangle is calculated as half base into height, wherein the height is the same as the slant height L of the cone. Let the base of these triangles be B1, B2, B3, and so on. The total area of all the triangles can be calculated as shown here. Taking half and L as common, we get the total area of the triangle as half slant height into the sum of the bases. Here the sum of the bases can be substituted as 2 pi r. Thus, the curved surface area of the cone is equal to pi r L, where r is the base radius of the cone and L is the slant height. Taking pi r as a common factor, the formula can be written as shown. Next, let's calculate the area of the base. The area of the circular base calculated as pi r square. Therefore, the total surface area of the cone is equal to CSA plus area of the base. Taking pi r as a common factor, then the total surface area of the cone is equal to pi r into sum of L plus r. Let's look into this problem. The height of a cone is 15 centimeters and its base radius is 10 centimeters. Find the curved surface area and the total surface area of the cone. Here, h is given as 15 centimeters, r is given as 10 centimeters. So using Pythagoras theorem, we find L, that is 18.03. Now, the curved surface area is pi r L, which is equal to 566.142 square centimeters. Therefore, the total surface area is pi r L plus pi r square, which gives us 880.142 square centimeters. Surface area of the sphere. What is a sphere? Is it the same as a circle? A circle is a plane closed figure whose every point lies at a constant distance, called the radius, from a fixed point, which is called the center of the circle. Now, if you paste a string along a diameter of a circular disc and rotate it as you had rotated the triangle in the previous section, you see a new solid. What does it resemble? A ball. Yes, it's called a sphere. A sphere is a three-dimensional figure, solid figure, which is made up of all points in the space, which lie at a constant distance called the radius from a fixed point called the center of the sphere. Now let's learn about the surface area of the sphere. The surface area of a sphere is the total exposed area of the sphere. Let's understand this further. Observe the sphere carefully. Let's draw a line on the sphere from one point to another on the opposite side. We'll paint it in one side of the line to the other side. Now the whole painted area of a sphere represents the surface area. An example that will help to easily visualize the surface area is an orange. If you peel the skin of an orange, the area of the skin represents the surface area of the orange. Is that the way in which we can calculate the surface area of the sphere mathematically? Yes, we can find it by using the surface area formula. If we have the sphere radius r, we can calculate by using the formula A is equal to 4 pi r square. You can observe that the surface area is equal to the sum of areas of 4 circles having radius r. Next, let's learn about hemisphere. A hemisphere looks like this. How is a hemisphere obtained? Here is the procedure. Take a sphere and cut it into half. Sphere gets divided into 2 equal parts. Each part is called a hemisphere. A hemisphere has 2 faces. A flat surface, which is called the base, and the curved surface. Now let's calculate the total surface area of the hemisphere. The total surface area of a hemisphere is the sum of the areas of the curved surface and of the flat surface. The surface area of the curved surface is exactly half the surface area of the sphere, that is 2 pi r squared. The flat surface resembles the circle for which the area is equal to pi r squared. Therefore, the total surface area of the hemisphere is the sum of the areas of the curved surface and the flat surface, that is 3 pi r squared. You can observe that the surface area is equal to sum of the areas of the 3 circles of radius r. Consider this example. Find the surface area of a sphere of radius 8 meters. Given r is equal to 8 meters. Now the total surface area is 4 pi r square, which gives 804.57 square meters. Now let's see an example to find the curved surface area and the total surface area of a hemisphere. Here r is given as 15 centimeters. So the curved surface area is 2 pi r squared, which gives us 1414.285 square centimeters. The total surface area of the hemisphere is 3 pi r square, which is equal to 2121.428 square centimeters. Let's see another example. A hemispherical bowl made of brass has inner diameter of 10 centimeters. Find the cost of tin plating it on the inside at the rate of 15 rupees per 100 square centimeters. Given, inner diameter is 10 centimeters. Now we find the radius r by dividing the diameter by 2, which gives us 5 centimeters. Now, the inner surface area is 2 pi r square, which gives us 157.143 square centimeters. Therefore, the cost of tin plating the hemispherical bowl at the rate of 15 rupees per 100 square centimeters is 23 rupees and 57 paise. Summary. The lateral surface of a cuboid is 2 into L plus B into H. Surface of a cuboid is 2 into LB plus BH plus HL. The lateral surface area of a cube is 4a square. Surface area of a cube is 6a square. Curved surface area of a cylinder is 2 pi RH. Total surface area of a cylinder is 2 pi r into r plus h. Curved surface area of a cone is pi RL. Total surface area of a right circular cone is pi RL plus pi r square, that is pi r into L plus r. Curved surface area and total surface area of a sphere of radius r is 4 pi r square. Curved surface area of a hemisphere is 2 pi r square. Total surface area of a hemisphere is 3 pi r square.